So let's first discuss squares and square roots. The square of a number, x, is that number times itself. A perfect square is the result of squaring a whole number. So let's first discuss this first statement. The square of x is equal to x times itself, x times x, which gives us a perfect square, which would be x squared. If we replace x with a whole number, in this case 4, the square of 4 is 4 times itself, 4 times 4, which is 4 squared, which is equal to 16. Now, radicals help us go from this value to figuring out what numbers can be multiplied to get to 16. And we have positive 4, but we also have negative 4. So the square of negative 4 is negative 4 times negative 4, which is negative 4 squared. A negative times a negative is positive. So again, perfect squares are the results of positive values being multiplied by each other. 1 times 1 gives us positive 1. 2 times 2 gives us 4. 3 times 3 would give us 9, so on and so forth. But negative 3 times negative 3 also gives us 9. Negative 2 times negative 2 also gives us 4. And negative 1 times negative 1 also gives us 1. So when we say the square root of 16, it would be positive 4 or negative 4. The square root of a number is the number that is multiplied by itself to get the original number. So the square root of 16 is equal to the number you would have to multiply by itself to get to 16, which would be 4 times 4, or negative 4 times negative 4. So these would be the square roots of 16. Now throughout this video, when we refer to the square root of a positive radicand, we'll just be discussing the positive square root, just to keep things simple. Let's discuss the radical sign, this right here. It is also called the radical symbol or the root symbol, and it indicates the square root or a higher order root of a number. So when there's no number place here, it is implied that the root is 2. When we have a radical sign in our expression, it is called radical form. Radical signs are used as a form of notation to represent fractional exponents. So what does that mean? When our term is in radical form, we have a to the power of m to the root of n. Now, in exponential form, if this exponent were a fraction, it would be this, a to the power of m divided by n. So these two are equivalent to each other. This is the radical form of the term, and this is the exponential form of the term, a to the m over n. Now, m is our power, and n is called the index. A, the number inside, or the base, is called the radicand. Now when we have a term in exponential form or radical form, remember the denominator here, or the index, must be equal to or greater than 1. It cannot be 0 or negative. And a must be a real number. So keep that in mind. When the index is equal to 2, it is usually not included in the radical form notation of a term. So if we have 4 to 3 halves, this would be equal to 4 cubed, 4 to a power of 3, to the root of 2. This is called the square root. So these two terms would be equivalent. It would be the same as not writing the 2. So when you are given this as the term, in exponential form, it is 4 to the 3 divided by 2. When this is not shown, it is 2. And remember to go back to exponential form to help you simplify these terms. This will come up later in the video when we are simplifying the expressions. So keep this in mind. The square root of a term a is equal to the square root of a term a. The 2 is written or not. These two are equivalent. Now let's discuss adding radicals. A radical can only be added to another radical if the radicand of each radical is the same. If so, combine the terms into a single term by adding the coefficients. Now the radicand is the term or number inside or under our radical sign. So these must be exactly the same in order to combine these two terms into one. And we do so, if they're being added, by adding their coefficients a and b. So a radical x plus b radical x would be equal to the sum of a plus b radical x. So instead of writing our radical twice, we can write it once. For example, 4 radical 2 plus 7 radical 2 is equal to 4 plus 7 radical 2, which would be 11 radical 2. And these are considered like terms because the radicand is the same. Okay, so when I say combine like terms, I mean the terms that have the same radicand. This would be an example of an expression that cannot be simplified any further. 4 radical 2 plus 7 radical 3 cannot combine because the 2 is not equal to 3. So this would be the furthest it can be simplified. 4 radical 2 plus 7 radical 3 is equal to 4 radical 2 plus 7 radical 3. The same if the radicands were variables. X is not equal to y. They represent different values. So these radical terms could not be combined either. Let's do some practice questions. Find the sum. Question number 1. -7 radical 3 plus 10 radical 3. Question number 2. 2 radical 4 plus radical 4 plus d radical 4. And question number 3. 3 radical x plus 2 radical z plus 2 radical x. Pause the video, solve these questions, and then press play when you are ready to begin. Step 1, group together the like terms. So in this particular question, we're only provided 2 terms, and they are like terms already. So this was already done for us. Step 2, combine the like terms by adding the coefficients. So we combine these 2 terms by adding -7 and +10, which would be +3, and we keep our original radicand, 3. So the answer to question number 1 is 3 radical 3. Question number 2, step 1, group together the like terms. In this question, again, each of the radicands are the same, +4, so we've already grouped them together. Step 2, combine the like terms by adding the coefficients. The coefficient to our first term is +2. The coefficient to our second term is 1. If nothing is shown, it's equivalent to 1, +1. 1 times anything would just be itself. So radical 4 is the same as 1 times radical 4. So that's why the coefficient is 1. And the third term, our coefficient is +d. So we can combine +2 and +1 to give us 3 plus d times radical 4. So this would be the answer to question number 2. Question number 3. Step 1, group together the like terms. So in this expression, 2 of our terms are like terms. Here we have x and here we have x. So we want these beside each other. And then step 2, combine the like terms by adding the coefficients. So 3 plus 2 would give us 5 radical x, plus our third term, 2 radical z. So this would be the answer to question number 3.